So let's go ahead and get started here. Let's say that, Lauren, what did we use most often as our weak acid? How do we usually write it? It's the general way. What do we call it? What was the chemical formula? You remember? The general formula for a weak acid, like the conjugate acid form. What do we give its chemical formula? You remember? HA. Okay. So that's our conjugate acid. Go ahead and see if you can remember what all these K reactions were. What was one of them that I'm talking about, Jessica? What's one of these K reactions? K what? Ka. Okay, there's one. Write a Ka reaction, and use HA as a conjugate acid. There's another K reaction. Albert, what was another K reaction? Kb. All right. So use HA to write the Kb reaction. And there's one more, KSP. So HA won't really fit into that one. Well, go ahead and write them out. See if you can remember how it goes. All right? How did we write each of these? And use HA as the conjugate acid where appropriate. Victoria, how did you write your Ka reaction? What goes to what? HA creates H plus and A minus. There's our Ka reaction, definitely. Conjugate acid goes to H plus and the conjugate base. Vanessa, how did you write your Kb reaction? Not HA. Okay, you're right. A minus plus, oh, you got it now, goes to hydroxide plus HA. The conjugate base plus water gives hydroxide. It's a base that's going to generate hydroxide plus the conjugate acid. Okay. Mari, what's the general way how to write KSP reactions? Yeah, proximal reaction. That's how you write the KSP expression. But what's the general way to write the KSP reaction? What's always the product? It has the solid, right? Now it doesn't have anything to do with acid, base, pH, that kind of stuff. It's just the solid going to its ions. So you have the solid over here, and its ions over there. Okay. And you had to know how to write every single one of these, otherwise, you can't even start the question. Here's the first one. What's the pH of 0.29 molar HF? Okay, now this is the game plan. This is what I'm thinking that I'd like you to do. If you open up this, let me see, grab your green book here. In this green book, right, if you open up to the very first day for this exam, day 21, okay, you find day 21, and it should be the page, yeah, there it is. It's the page right before it starts. You see that? That's your exam 3 equation sheet. This is the only thing that I want you to have out when we're working these questions. So if you're not sure how to do something, ask the people next to you, or ask me, right? Okay, and we'll go through these one at a time. So this is the only thing you should have out. This in the calculator. Now the one thing that's missing is the KSP table. It's supposed to be on the back, but it isn't. So if you need a KSP, I'll just look it up and tell you. Okay, but have this staring at you. Okay. Oop. So here's your first question. What is the pH of 0.29 molar HF? See if you remember how to handle that question. All right, now try to only have that exam 3 equation sheet out. Ask the folks around you if you're not sure, but they look like they're writing something. All right, the more explaining you're doing to other people, the more productive this will be. Nobody's saying anything. So that means everyone knows what to do? Ramiro, what are you going to do? Write out what reaction? The Ka reaction. And then do ice. Exactly. Because you want to know the concentration of hydrogen ion at equilibrium. So you can take the negative log of it and get pH. Exactly. So write the Ka reaction for this. How do you know how to write Ka and not a Kb reaction? It's an acid. It's got an H out front. HF. Yeah. Aha. Thank you. Oh, is that the one I know? Yeah. All right. So hopefully you're getting this far. Anybody get an answer for the pH? No? See if you can get it. What was the trick to do? What's the trick to doing this next? Drop. Why can you drop the negative x? Because it's so small, and the only reason why you can say it's so small is because 10 to the negative 4, right? 10 to the negative 4 is iffy, but it's okay. Really, that's what we decided in class. But 10 to the negative what is not? 3, 2, yeah. So this would be a mean question if it was 10 to the negative 3. You do a full quadratic expression of it. Take 6.8 times 10 to the negative 4 times 0.29. Take the square root. For the pH? A lot of people are getting 1.85 as a pH. Okay, what'd you get for your x? Just 0.01. Okay, so is everyone comfortable with this? Okay. And we wrote a Ka because it's an HF, right? It's an acid. How could I have made this a trick question? Instead of writing HF, write H what? And then hopefully you're not going to write ice, is what I'm getting at. HI, a lot of those halogens. HCl, HBr, HI, they're all what? strong acids. And if I would have said that, HI, well, then your concentration of H plus is 0.29 molar. So it's really easy to take pH then, but it's not that. Right? Okay. So let's take a look at this one. What is a POH of 0.023 molar HNO2? It's POH, so write a KB reaction. Mari's saying, why not? Yeah, that doesn't change what this guy is. He's an acid. So you have to write a Ka reaction. You have to. Maybe get pH and then subtract it from, do you remember that? From 14 to get POH. That's how I would do it. I think it's less plug and chug. Use this one. What did you get, Maria? 11.5 is POH. One person got 11.5. G 11.5? Okay. Hopefully you're getting 11.5 for the second one. Good. If you got 11.5, look at both these answers and see if they make sense. Right? Because hopefully you'll have a minute or two on the exam to look at your answers and see if they numerically make sense. Like, does the 1.85 make sense? Yeah, it should be acidic. It should be a number less than 7. Yeah, it should be a number less than 7. And it is. Okay. Okay, so I'm going to get rid of some of this stuff. 11.5 is what. So I'm going to skip some of this and see if you can go ahead and move on to the next one here. 0.9 molar N2H4. That hydrazine. And remember, all you have available to you, that exam 3 handout. Mm-hmm. Yeah, because whatever molar or something, whatever that something always has to be here, and it's a base. So, yep, exactly. And I like writing the H out front too, because it's obvious that it's a conjugate acid. I think you just forgot your 4. It's supposed to be a 4, N2H4, but it looks good. If you're working on 3, hopefully you're writing a K what reaction? B. Because this guy is in that base table. Okay, B reaction would you write? Yeah. So it'd just be him, just write him, copy him verbatim. Goes right there. And then his conjugate acid, just add him an H. Well, technically an H plus. They want pH. Oh, but you're getting, that's OH negative. So take the negative log of it, you get POH, you're right. Yeah, use this. This is your guide here. There it is. Anybody get an answer for 3? 3.2, 8.3. I would buy this answer because it's a base. So don't see if you get an acidic answer, you did something wrong. All right, because they're after pH, and it's a base. You said 3.2 or something. Oh, 8.2. 11. A lot of folks are getting 11. 11.1. Okay, so folks are getting a pH of around 11. Okay, so you're comfortable with 3? Try number 4 then. What did you say it was? Strong base is NaOH. Strong bases are pretty much just group 1s with an OH. Those are the strong bases. That'd be a good trick question, right? With the pH of 0.9 molar NaOH. All right, number 4. Which type of reaction are you going to write? Is this going to be a basic or acidic solution? Good. Did you hear what Alyssa's talking about? You don't look at Na. All that's left is Cn, well, technically Cn minus. That's the conjugate base of HCN. So all you have is the conjugate base in solution. This is going to be a basic solution, a Kb reaction. So you have to write a K what reaction? Kb. You have to. It's a base. And I would leave the sodium part out. Yeah, there's an expression at the top that allows you to calculate Kb. You have to see, there it is.
Oh, yeah.
You have to calculate Kb. Now there's an expression on the top of that equation sheet for exam 3 that will allow you to calculate Kb. You have to calculate Kb. Can't find it in the table. So 10 to the negative. Lauren, did you get an X? Did you get an X for number 4? I don't know. Is it? What did you guys get? 1.35 times 10 to the negative 3 for your X? No? What did you get for your X? Yeah, somewhere around 4.3. Victoria, you got that? Make sure Lauren's got that. Okay, so if that's my X, the advantage, it's not, to me, it's not worth the risk. If you skip this, because you're so comfortable writing X squared over, right? You may forget that X is really hydroxide here, right? So that's just a danger if you don't write the ice table, I think. So take the negative log of it, you'd have POH, subtract from 14, you get pH, and the answer is around 11.6. Okay. There we go. Yeah.
If we don't write down the calculations or like the pH, the pH equals or like for those formulas,
If you skip, good question. If you skip any part in here, right? Because this is showing every step. If you skip any part in here, right, and you get the wrong answer, you get nailed even harder. Because I'm not sure where you're getting your stuff from. So the more work if you showed all your work, all of it, and you just screwed up with the final answer, it's only 1 point off. If you get the right answer but don't show your work, it's still everything off. So you got to show your work. And the more you show, the more partial credit you would get if you don't get the right answer. Okay. No using the book. No using the book. All you have is the equation sheet staring at you. The answer is in the equation sheet. The answer is there. All the little steps are right there. You just got to find it. There's one word. To me, there's one word in this question that tells me where to look and what to do on that equation sheet. What's the one word that I'm trying to get you to see? Buffer. Buffer. All buffer problems have their own equation. I don't remember the guy's name, but Henderson-Hasselbalch. Right? Any buffer problem, that's all we used for that equation. You have to find it. Find it on that equation sheet. It's right there. Right? What equation am I talking about? pH equals pKa plus the log. Okay, now we modify. I can write concentration of the base over concentration of the acid, but the volume cancels. So it's so much easier. This is how we did it in class. We modified the book's equation. I give you the book's equations, so that's why it looks a little bit different. And you can calculate concentration. Just your liters are going to cancel out on you every time. That's fine. It's a little extra work. What is pKa? Negative log of Ka. Little p always means negative log. So if it's pH, negative log of H. pKa, negative log of the Ka. So you have to find the negative log of the Ka. So you're going to need that number. Then you're also going to need the numbers moles base and mole acid. So how are you going to get some of these? How are you going to get this one, for example? Yeah, use the molarity. You can write the big M equation for the acid, or you can just realize big M is moles over liters, multiply big M times liters, and you got moles. Right? Either way works. So to get the moles of the acid, here's my acid stuff. Or would I use the total volume? No. Yeah, you want just the moles of the acid, so you better just use the 300 mil. Now, these types of questions, you really want to show all your steps. If you show all your steps, it's going to make your life a lot easier to do Part B. 0.246 moles of the acid. 246. Yep, negative log of the Ka. What'd you get for the moles of the base? 0.1875. Base or acid? Okay, especially this equation with the stars on it is the one you really want to show everything because you're going to need that to do the second part. Okay. I don't know. What did you get? 7.3? Monica got 7.3 as the pH. Okay. A lot of people are saying 7.3. Okay. Okay. It's a buffer. It's a buffer. So you have to have conjugate acid and conjugate base there. Because if you add any acid or base, the pH is supposed to stay at 7.3, or really, really close. If you add some acid, the conjugate base will react. Add some base, the conjugate acid will react. There you go. Okay, now that's summary. You're getting there. That's what you have to do for part B. You have to. Okay. You're adding oh, but not to the whole buffer. You're only adding. You're adding some acid here. Right? So the pH is going to go down a little dinky bit, but not very much. So if you're going to guess, maybe 7.2 or something, right? I don't know. But it shouldn't go down by too much. You're only adding to 100 mils of the buffer. Now it's a buffer question, though. So what I strongly suggest is copying what equation up here? Yeah, that bottom one, that one with the stars. Then we're going to do what Summer was talking about. Did you hear what she said? Yeah, you're going to add and subtract some number. It's going to be the moles of the acid. Now, which, here, let's write this down first. pH equals negative log of 3.5 times 10 to the negative 8, whatever that was, anyway, plus the log okay. Which one is it? Do I add or subtract? And there's some number. Do you remember? On top, I'm going to add or subtract. I'm going to subtract. Why? I'm adding an acid. Only what reacts with this acid? The base. The base is up on top. So something has to react with the acid. Otherwise, the pH is going to drop like a rock. So the conjugate base reacts with it. So we are going to have a minus on top. Well, all that gets converted into moles of conjugate acid, so we have to add on the bottom. And what's this number that we're adding and subtracting? What's this number? Yeah, it's this thing. Okay, that's what that number is. Now, if they wouldn't, this would be great, we'd be done if they didn't say what? The 100 mils of the buffer. If they wouldn't have said this. If they wouldn't have said this, they added to the whole buffer. We're done. Well, you got to do it in the calculator, but you'd be done. But they only added it to 100 mils of the buffer. Now let's pretend that they added it to exactly 1/2 of the buffer. They divvied the buffer up into 2. They added the HCl to exactly 1/2 the buffer. What fraction would you put in front of these moles of acid and base? 1/2, right? If it was 1/2. But it's not 1/2. It's, I don't know, what is a fraction? 100 divided by? 550. Yeah, divided by 550, because the whole volume is 550. And then we took 100 of it. So 100 divided by 550, whatever fraction that is. 100 divided by 550. Now we're complete. Oh, no, I got to figure out what that number is, right? 0.02, gosh. 0.025 liters times 0.35 moles per liter is, what did you say, Monica? 8.75 times 10 to the negative 3. That's the number we have to put in right here. Okay. There's a lot of places you can mess up. And it's the log of this whole big thing. Right? And you know you did it right if you get an answer around 7 point, I don't know, something a little bit less than 7.3. Then you know you did it right. Vanessa, did you get an answer? 7.1. It's believable. Did anybody else get like 7.1? Okay, several folks did. Because the base has to react with it. So its moles is going to go down. If you add a base, then the acid has to react with it. You got to subtract down here and add up there. All right. So we're about out of time. But you've got the handy dandy fun sheet. And look at all the fun you get to have. So jealous. Right? Monday. And then we'll have additional review on Monday. Probably have I forget, PHS or SOS on Tuesday.
Inside the log on the right side, would you have to subtract that 8.75 times the negative 3 before you multiply?
No, I would. No, you have to do multiplication and division is before subtraction. So you have to take 100 divided by 550 times 0.1875, then minus your number. Because your calculator's smart enough to do all the multiplication and division first. Or you could always hit equals, right, if you're not sure.
I did the other way. I did the subtraction and the addition before multiplied, and I still got some.
No. That won't work. 7.3 is wrong.
What did you say?
So, have a good weekend. Have a good day. Have a good weekend.